Okay, so let's have a quick look at NTP4. Now, by default, we're running NTP version 4, but we will respond to packets that come in from earlier NTP versions. By default, we're also running unauthenticated. And what that means is that if a packet comes in unauthenticated, we'll reply to it. And if it comes in with the correct authentication, we will as well. Now, Juniper strongly recommend authentication on NTP for clear reasons. One of those is the way that the symmetric active is handled. We'll come to that in a moment. Okay, so in order to be an NTP server, you also have to be receiving time information from another source. And so both clients and servers are going to have servers configured. Set system NTP server, and again, we strongly recommend the key number here. And then of course, we can specify what key we're using, and then we can specify the key value as well, the MD5 value. Okay, so clients and servers look vastly, for the most part, they look the same. The server may be in broadcast mode, and that means that on a given time period, it's going to be sending out NTP messages using the broadcast address, and then any clients can pick them up. And of course, it can specify the key number and the version, etc. Now, there's another mode here called symmetric active. Now, in the standards, we have symmetric active and we have symmetric passive. And it's almost as if a Junos is left in symmetric passive by default, because if you are in symmetric mode, either end can actually initiate it. So all that would need to happen would be a peer would need to be typed in, peer address, then the key, the version, and whether or not you're preferring this particular peer. Now, the idea of peers sort of defaulting to each other for network timing may seem a bit strange, but what happens is they default to the lowest stratum. So if two peers are working together and one of them was to disappear, for example, then the time server could pick up its time stamping from another location. So it's there for resiliency. If one particular pair suddenly gets hold of a much better stratum, a much lower stratum, then the others would sync to that peer. So because we're effectively symmetric passive by default, because the other end could configure the peer address if we're using network time protocol, Juniper really do strongly recommend turning on the authentication. That would stop somebody else from peering up with your network time daemon. Just a couple of things that I noted here. You can be a multicast client. Take note of the IP address. It's slightly unusual, 224.0.1.1. So if you're a multicast client, you'd be listening on that address. Okay, so how exactly does the synchronization work? So by default, it will allow 128 milliseconds of drift, and then it will immediately bring the client back into line. So within that area there, it will immediately bring it back into line. Now that's milliseconds. Now, if that drift gets very large, it will still bring it back into line. But when you reach the threshold of 1,000 seconds, it will also log that something untoward has happened. Now you can actually change that threshold action to reject the change. So if your NTP server suddenly did a very large jump in time, you can actually reject that past the threshold if you had set the threshold action to reject. But by default, even if the action gets quite large, it will accept it, but it's going to log it at 1,000 seconds. So just those numbers again. So 128 milliseconds drift is automatically stepped back into line. 1,000 seconds is the default for receiving the log message, but it will accept the time difference. If you want to manually set it, it's 1 to 600 seconds. You can change the actions of the threshold from either logging or rejecting.